Does the mass of an object really increase with the increase in the speed of object? And of course, the speed should be comparable to the speed of light. Well, it is not that much simple as you think. It is a very deep concept. So let's understand this video. Hello everyone, this is Aditya, and today we are going to discuss this topic only. So please do like, share, subscribe my channel, and please support this video. Now let's understand this concept. So to understand this concept, let me introduce you something called rest mass. Well, what is rest mass? If I tell in simple words, rest mass is basically the mass of an object when it is at rest, right? If I tell in simple words. Now let's come to relativistic mass. Well, relativistic mass is basically the mass of an object when it is in motion, right? Okay. And this mass becomes more prominent when the velocity of the object approaches to the speed of light, right? Now here's the catch. Does the mass really increases or there's something else? Well, there's something else. Now as we all know that as the velocity of an object increases, the kinetic energy of the body also increases. Since we know that the kinetic energy is proportional to the velocity square, but this is only valid for classical mechanics. When we go to relativistic mechanics or relativity, then we find that kinetic energy is not equal to this. It is actually a different expression. Basically, kinetic energy is equal to half mv square multiplied by an adjusting factor which we call Lorentz factor, right? Lorentz factor is basically equal to 1 upon square root 1 minus v square by c square, where c is the speed of light in vacuum, that is 299792458 meter per second, and v is the speed of the object, right? Now if we consider classical mechanics, which states that kinetic energy is equal to half mv square for any range of velocities, then in that case you will end up getting that yeah, the object can move faster than speed of light also, right? But when we take the kinetic energy formula with respect to relativity or relativistic mechanics, then we come to the conclusion that no, it is not possible for any object in this universe to travel at speed of light which has rest mass, right? But notice that photons don't have any rest mass, so that is why they can travel, and they do travel at the speed of light, right? Understanding or not? Now the key thing over here is that as the velocity of the object is increasing, so is the Lorentz factor increasing, and so is the velocity of the object is also increasing, which means that overall kinetic energy is increasing of the object, right? But as it is tending towards the speed of light, the velocity of object, then in that case the kinetic energy is tending towards infinity, right? Since when you substitute v is equal to c in the formula, then the gamma tends towards infinity, so kinetic energy tends towards infinity too, right? So it means that any object which has rest mass when attains the speed of light will have infinite kinetic energy, but that is clearly a nonsensical thing, right? So basically this increase in kinetic energy is termed as the increase in the relativistic mass. Now to account for this difference in kinetic energy that the classical mechanics gives and the relativistic mechanics gives, we define a term relativistic mass, right? Which is equal to, that is m relativistic is equal to m rest mass multiplied by the gamma, right? Where gamma is the Lorentz factor, right? So in that case, we term this mass as relativistic mass, right? So basically the increasing kinetic energy is basically accounting for this increase in mass, right? So that is the basic idea, right? And there's a lot to be discussed in this, but of course we don't need to go that much detail right now. Of course, if you all want to know more about it, I'll make detailed videos on it, right? But for now you can understand it like this only, right? So if you did enjoy this video, then please do like, share, subscribe my channel, and we support this video. Bye bye, take care.